A very good morning, children. In the yesterday's session, we learned what is the relationship between the equilibrium constant Kc and the reaction coefficient Q as well as the Gibbs free energy relationship. We remember the Gibbs free energy relationship what we got? Delta G is equal to delta G naught plus RT ln K is the relationship that we got in yesterday's session. At equilibrium, when we have written the equation delta G naught is equal to minus RT ln K. Up to here, we learned in yesterday's session. Is now. Now, based on that, we are going to see some numerical problems in this video. Then we will relate some logarithm values, how to extract and how to calculate. So, based on this formula, let us see some problems here. The question that was given is the value of delta G naught means standard Gibbs energy. What is this one? Standard Gibbs energy. For the phosphorylation of glucose in glucolysis is 13.8 kilojoule mole inverse. Find the value of Kc at 298 Kelvin. At 298 Kelvin. Whenever this delta G naught and Kc comes, we need to remember this equation. Which equation? Delta G naught is equal to minus RT ln K. Here the point comes for you is ln is the natural logarithm form. This is the natural logarithm form. We need to convert this one into log base 10 form. Log base 10 form. When you are converting that into log base 10 form, it is equal to 2.303 into log base 10. ln means the natural logarithm form. When you are converting into log base 10 form, it is equal to 2.0303 into log base 10 value. So here we are writing the above equation also as minus delta G naught is equal to delta G naught is equal to ln is there, right? For that we are bringing 2.303 into R into T into log base 10 Kc. It is the equilibrium constant term. It is the equilibrium constant term. So our modified equation in the log base 10 format is delta G naught is equal to minus 2.303 into R into T into log base 10 into Kc. So this is what the formula that we will use in the calculations. Okay, student. So before we go forward for these calculations, some basics about the logarithms we need to know. Some basics about logarithms. Some basics about the logarithms. What do you know about the basics of logarithms? Some values we shall have a glance here. We know some important formula here regarding the log. We are writing log A into B. This is one of the very important formula. Log A into B we write as the log A plus log B. Okay. Now one more important formula is log B power A. Log B power A. Log B power A will write as A into log B. Into log B. These are the two important formulas that we regularly use in our calculations purpose. Now, before we go there, let us see the log values for some values up to log 10. We have the log base 10 1, log base 10 2. Every time we need to write log base 10 2. You can simply write log 3, or you can write log 4, or you can write log 5 directly. This is indicating that these are all equal to log base 10 format. Okay, children? Log 8, log 9 and the log 10. Log 10. Log base 10 values. These are all related to log base 10 values. Log base 10 one value is only 0. Very simple. Log base 10 two value is 0.3. How much is this one? 0.3. Log base 10 3 is 0.47. Log base 10 4 is 0.6. 0.6. Log base 10 5 is 0.7. Log base 10 6 is 0.77. Log base 10 7 is 0.85. Log base 10 8 is 0.9, 0.95, and log base 10 value is 1. At times, when you are working with objective examinations, you can see here the log base 10 2. What is value children? 0.3. Now we have the log base 10 4. Can you write this also as log base 10 2 to the power of 2 to the power of 2, or can you write as the 2 into log 2. Where did you got this formula from? You got this formula from log b to the power of a. You are writing it as a into log b. So we are writing 2 into log 2 value. What is the value of log 2? 0.3. 0.3 is nothing but 0.6. Log 8. How shall we write? Shall we write this as log 2 to the power of 3 children? How we are writing children? Log 2 to the power of 3. Or can you write as 3 into log 2, or 3 into 0.3, that is 0.9. So I am highlighting these points because in our calculations this will make our work easy. Done. Now please write down this data. Yes, very good. Now we are going to learn something about log values, how to work with, and anti-logarithm values, how to work with for few examples. Then it will make our work very easy. Write down those points, children. Good. If a question is given to you, means in some problem you are going to face to solve a numerical line, you need to solve log 2 into 10 to the power of 13. What you are going to solve? Log 2 into 10 to the power of 13. No need to work with the log tables. You can write this one as, can you find this is as first of all log a into b. How is this one like? Log a into b. How will you write this one as the log a plus log b, or we are writing as log 2 plus log 10 to the power of 30. Log 10 to the power of 30. Now can you see this is again log b to the power of a, this second part log b to the power of a. How we are writing? A into log b. So log 2 plus 13 into log base 10. This is all log base 10. What is the value of log base 10? Log base 10 value is 1. So this is what equal to 1. But what is the value of log 2? Log 2 value is 0.3. So 0.3 plus 13, how much you are getting? 13.3. So that's what in a very simple method you can keep in mind. Don't for a log base 10, log 10, or this log 10 formula, log base 10 or log 10 value is 1. Value is 1. So if you want to see about some anti-logarithm values, any value you take, I am taking here anti-log of 4.6. First of all, you must break this one. Presently in the above I have taught you how to work with logarithm. In the next one we are seeing how to work with the anti-logarithm values. Anti-logarithm values. Some anti-logarithm 4.6 is there for you. Then you must take these parts into two variations. Like first you write the given value as anti-log of 4 plus remaining part is there now. I am writing that as 0.6. I am writing that as the 0.6. Means first part I have written as usually, remaining part I have written as 0.6. But now We are expressing this one in another format. Let us see here children. 4. I am writing it as the log base 10 to the power of 4. Means log 4. Tell log base 10 to the power of 4. Why I have written this one? Because can could expect like log base 10 to the power of 4. Can could write this one as the log b to the power of 8. How we have written this one as a into log b. So shall we write this one as 4 into log base 10? 4 into 1 is nothing but 4. Because log base 10 value, how much it is? Log 10 value is 1. So it is equal to 4. So the 4 we are writing as log base 10 to the power of 4. Now remaining part is there, right? 0.6. From the data, you find 0.6. 0.6 is nothing but it is equal to log 4. It is equal to log 4. It is equal to log base 10 4. Log base 10 4. Now it's not log base 10, it is log 10 to the power of 4. For the function log 10 to the power of 4. See, log a plus log b. Log a plus log b. Can I put this one as log a into b? Or we are writing this one as the log a into b. So anti-log of 10 log of a into b. Log a plus log b format we have. So we are writing this one as the log a into b. Or I would like to say log 4 into 10 to the power of 4. I am bringing the part forward. The anti-log and log we can cancel out each other and is equal to 4 into 10 to the power of 4. It is equal to 4 into 10 to the power of 4. In this method you need to work with the anti-log values. First you take the value whatever is given. 4.6 means first you write 4, then you write 0.6. Then 4, how you are writing log 10 to the power of 4. Then you are taking the 0.6 from the logarithm value. 0.6 is log 4. So we will bring the log 4. This is a log a plus log b. Or we can write log a into b. So I am writing this one as the 4 into log 4 into 10 to the power of 4. So anti-log and log will be cancelled out. So we are having 4 into 10 to the power of 4. This is what very basic important for doing these numerals. Let us see this question here. The value of delta G naught for the phosphorylation of glycolysis is 13.8 kilojoules. They will give you in form of kilojoules. Whenever you are coming to this delta G value, you need to convert it into joule format. Which format you need to convert it into? Joule format. Why? Because there the gas constant is 8.314. Right? 8.314. So find the value of Kc. What is the formula we know? Delta G naught is equal to minus RT ln Kc, or delta G naught is equal to minus 2.303 into R into T into log base 10 of Kc. What is the delta G value? G naught value is given 13.8 kilojoule mole mass there. But you express that into joule. For the time multiply with 1000 or 10 to the power of 3. Joule mole mass is equal to minus 2.303 into R 8.314. Last session we got whenever you have delta G, you must take R value 8.314. And temperature, what is the temperature given? 298 into Kc. Log base 10 of Kc. But do we know the value of log base 10 of? Can we arrange this part? So it will be clumsy if we bring very close. 298 into log base 10 of Kc. What we need to calculate? We need to calculate the log of Kc. So it is becoming as, when you bring on this side, it is becoming as 1 by log Kc is equal to 13.8 into 1000 upon 2.303 into 8.314 into 298 into 298. Once please check the value and say to me how much we are getting, children. Is it around 2.418? 2.418. So 1 by log Kc is equal to 2.418 got. Or can you write as Kc is equal to the log I am taking on the other side. 1 by Kc is equal to the log that is coming on other side, we can write as the anti-log of 2.418. See this step I brought like 1 by Kc is equal to anti-log of, log comes on right side, anti-log of 2.418. In the last point we had seen how to work with this. Anti-log of 2.418. How you will split, children? Anti-log of 2.418. How you will write anti-log of 2 plus 0.418. Or you can make it as 0.2. Rounding. However, rounding 0.4. Or we can write this as anti-log of log base 10 to the power of 2. I express it in the form of log base 10 to the power of 2 plus 0.42. 0.42 means it is between 2 and 3. Between 2 and 3. Because 2 value is 0.4, 3 value is 0.47. Right. So we are writing the as 2.6 approximately. I take as the 2.6. Now log 2 value, what do we know? Log 2 is equal to 0.3. Log 3 is equal to 0.47. Log 4 is equal to 0.6. These are the values that we know. But here between 0.2 and 3, but the value what we got is 0.42. Some taking in between value, like between 2 and 3, it is like 2.6 I have chosen. Now, shall we say this is in the format of log a plus b. This value is log value, right? This is log 2.6. So, log a plus log b. How shall we write? Log a into b. Anti-log of 2.6 log 2.6 into 10 to the power of 2 into 10 to the power of 2. Or we can cancel this log and anti-log. How much will be like 2.6 into 10 to the power of 2. So in this method, first we need to get your value. So for the anti-log of 2.418, how much I got? 2.6 into 10 to the power of 2. To understand those, we brought the basics for us. Now let us continue our calculation. This is the rough data that is useful. Now 1 by Kc is equal to 2.6 into 10 to the power of 2. Or we can write Kc is equal to 1 upon 2.6 into 10 to the power of 2. Is it not, children? How much it is that you are getting? 1 by 2.6 select. Is it not 0.38 into 10 to the power of minus 2. This is in the denominator place, it is going for the numerator place and as the 10 to the power of minus 2. I am not taking much decimal, I am taking very less decimal here. We know in the first year, whenever we are expressing our value, it must be between 1.0 to 9.99. Whenever we are writing in scientific notation, we must enter that value in our decimal in that value. So here, I would like to send it next, or can you write as 3.8 into, it is going to right side, decimal is going to right side, so it will become a negative value. 3.8 into 10 to the power of minus 3. 3.8 into 10 to the power of minus 3. That's what is for the Kc value. Right now, we will check with one more numerical. Let us see the next question here, children. Hydrolysis of sucrose gives sucrose plus water gives glucose plus fructose, that is an equilibrium. The equilibrium constant Kc for the reaction is 2 into 10 to the power of 13 at 300 Kelvin. Calculate delta G naught at 300 Kelvin. What is the formula that we know? Delta G naught is equal to minus RT ln Kc, or we can write this one as delta G naught is equal to minus 2.303 into R. R value is 8.314 joule mole inverse Kelvin inverse. What the temperature we had? Temperature was given as the 300 Kelvin into log, because what is the value of Kc given here? 2 into 10 to the power of 13. Log 2 into 10 to the power of 13. Now let us find out this point. Log 2 into 10 to the power of 13. Log 2 into 10 to the power of 13. How shall you write tonight? How will you write? Log A into B. Log 2 plus log 10 to the power of 13. Or we can say what is the value of log 2? 0.4 plus 13 into log base 10 of 10. This value is equal to how much? 1. So how much we are getting? 13 point log base 2 value is 0.3, right? So 13.3. How much we are getting? 13.3. So you can substitute the values here, minus 2.303 into 8.314 joule mole inverse Kelvin inverse 300 Kelvin into 13.3. Cancel the Kelvin and Kelvin inverse. The final unit will be joule mole inverse. You do the calculation. I hope you understood how to apply the formulas for the numericals that we learned yesterday. In the next session, we will see what the effect of concentration, pressure and temperature on the equilibrium. Thank you, children. Have a nice day.